it's review time!
Celebrate test time, come on!
Woohoo! Okay, so tomorrow's test day. Hello, review day. We're going to review what our test is over and everything that we've done so far this school year, actually. Our learning target is we will be able to sort, compare, and order real numbers by estimating them as rational numbers. You probably heard a lot. You know this, backwards and forwards. Between what two whole numbers does negative square root of 35 lie and graph on a number line? So I have to go, negative square root of 35, and I should have put, between what two integers does this lie? My mistake. So Ms. Green, how do we solve this? Look at that, a handy dandy calculator. Look, you can see we were still doing last video on it.
It's okay, I know.
So negative square root of 35 equals negative 5.916079783. Ooh, that's a big number. It's irrational. So I'm going to stick it between which two integers?
-5 and -6.
So -6, -5. Is it going to be closer to -5 or -6?
I don't know, it's 5.9. It's pretty darn close to -6.
It is pretty darn close, so I'm going to graph it right here. Negative square root of 35.
Awesome.
Ooh, that was easy. Man, this test is going to be easy.
I know.
So which sets or subsets do these numbers fit into? Miss Green, my eyes are really bad.
I know. This is just ridiculous. Okay, so we've got negative square root of 51, square root of 9, 3/4, -1/2, -6, 0, and square root of 11. And then we've got this right here. Even if we try and zoom in,
Coach Groves has really tiny handwriting.
So you are going to have to put these into, we've got real numbers. All of these are real numbers. And then, of course, we've got our rational numbers, our rat numbers. And then we've got our integers, our whole numbers, and our natural numbers. Okay, and then, of course, outside, we've got a tiny box over here set aside just for our irrational numbers. So
what I want you guys to do, take a minute, pause the video with these numbers on it. I want you to draw this chart, and I want you to put them into your journal.
Now, I have to say this because I've said it several times, but I feel like not everybody's listening when I say this, so listen carefully. Remember, all natural numbers are whole numbers. All natural and whole numbers are integers. All natural, whole, and integers are rational numbers. Okay, so if I have, let's say it's not on here, but let's say I had 7. 7 is a natural number. I don't have to put it in every single one of these. I only have to put it on the first one.
It's already included in that by being inside the whole number circle.
That's right. Okay, so just keep that in mind. So you only have to place these numbers once. Place it in the set that it belongs to primarily. Okay, so take a second.
Pause it. Set these in the right one. And we'll be back in a second.
And we're back.
Woohoo! Here we go. We've got our real number systems. Ms. Green has written this out for us with really bad eyes that Coach Groves can't write. She just likes to write small. Let's just go over that. So we've got the rational numbers were 3/4 and -1.5. I'm sorry, -1/2. Yeah.
Yes.
Integers were -6. Whole was 0. Natural square root of 9 because that equals 3.
It is exactly 3. Had it been the square root of 10 or 8, that would have been an irrational number. So Here we go. Irrational numbers.
And your irrational numbers were square root of 11 and negative square root of 51. I hope you got all those correct. And again, that you noticed, as Miss Green just mentioned a little bit ago, that square root of 9, I didn't have to put it in every category. We knew it was in natural, so it's automatically in whole, automatically integer, automatically rational, automatically real.
Okay, moving on.
Converting to scientific notation. This one was fun. Now, first step for scientific notation, we had to have a number between 1 and 10. So my number between 1 and 10 here, I have to include everything that's not a 0, would be 3.501. And then...
Sorry, I can't see it very well.
My decimals are small too. Then we move our decimal and go 1, 2, 3, 4, 5, 6, 7, so times 10 to the 7th. And remember, when it's a really big number, your exponent is?
Really big.
Or positive.
Or positive. That's right. I don't know why I said really big.
And then, when it's a really small number, our exponent is?
Really small. I mean negative.
So now, we've got 0.000201. I think I said the right amount of
0.000201.
Yeah, sure.
I said it right for
Okay, yes. So our number, we're going to put that decimal right there. So we've got 2.01. Is that decimal big enough?
Yes, thank you so much.
You're welcome. We've got 1, 2, 3, 4. So times 10 to the 4th, right?
Yep, that's it.
No,
Wait, you tricked me.
Times 10 to the negative 4.
That's right. Don't forget.
So you got to remember that negative. Now let's convert from standard form, convert to standard form from scientific notation. So we start with our 6.5, and it's negative.
That means it has to go to the left. Remember, less is left.
So 1, 2, 3, 4, 5. That's my new decimal. 1, 2, 3, 4. So it's 0.00065.
Awesome.
Now this next one, I'm gonna write my numbers in here. And I'm going over 9, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Whew, that's where my decimal goes. And add in zeros. Okay, and that's the answer. Woohoo! So now, what is the difference between 6.5 times 10 to the 5th and 3.1 times 10 to the 6th?
First thing we're going to want to do is go ahead and convert them to standard form.
So 6.5 times 10 to the 5th is going to be right there. For those of you that need to count it out, just write it in your journal and draw in the lines. I'm going to put the other one on top because I do know it's greater, because that exponent's greater. That means it's a greater number. And it's actually that number. Again, if you needed help converting that, we just went over it. And then I'm just going to subtract it, because difference means to subtract.
And all these zeros, you just bring them straight down. There's no subtraction there.
Easiest thing ever, except for that one. Now I have to borrow. I'm going to borrow from the 3, because I don't like it when there's one that I take away 1 and there's nothing there. So 10 minus 5 is 5. 10 minus 6 is 4 and 2. My answer is right here if I want to convert that back to standard notation.
Scientific notation.
Scientific notation. I lost count. 1, 2, 3, 4, 5, 6. So 2.45 times 10 to the 6th.
If it makes it easier, I've noticed, and I haven't really said this to y'all, if you put commas in there, you can actually count it better. So here's a comma there, here's a comma there. You'll see that that's obviously to the 6th power.
Yes.
Okay, moving on. Oh, we have nothing else to move on to, you guys.
That's our unit.
That's it. Oh my gosh, I can't believe that it's been an entire unit and we've done this all through video. This is amazing. Okay, well, we wish you the best of luck on your test. Come see us if you need us. And
if you're really confused, as I put on here, watch any video you're confused on. If you are struggling with scientific notation, there's a video you can rewatch.
That's right.
So go ahead, make sure you're ready for this test. I hope to see lots of amazing grades.
All right, see you guys next time.
Bye.